Like a lot of kids, I grew up reading about neutrinos and people speculating about doing neutrino astronomy. And here I am, doing neutrino astronomy. I feel like I need to pinch myself. My name is Rupesh Ojha, and I'm an astronomer working at the Goddard Space Flight Center. I work with the Fermi Gamma Ray Space Telescope. What we have been able to establish for the first time is an individual blazar as a potential birthplace of an individual neutrino. The Fermi Gamma Ray Space Telescope has an instrument called the Large Area Telescope, which we use to monitor the gamma ray sky, the highest energy electromagnetic band. And we just noticed that there was a tremendous increase in the amount of gamma ray light coming from this one extragalactic blazar. A blazar is an extremely powerful variable galaxy that is powered by a supermassive black hole. It went up not by a little bit, not by a few percent. It went up like 15 to 30 times its average flux. So we knew something was afoot. Later on, it turned out to be coincident both in time and in space with the neutrino that was detected by IceCube. IceCube is a neutrino telescope located at the South Pole, or to be more precise, under it. It consists of over 5,000 detectors that are spread out into a cube about 1 kilometer on each side. It's the world's biggest and its coolest telescope. So a neutrino is an incredibly small particle. It moves almost at the speed of light. It is nearly massless. It's incredibly plentiful, but it's very, very hard to detect because it will not interact with just about anything. If you could detect them, though, because they have traveled through the universe essentially undeflected, they have information that you could not access in any other way. IceCube has detected a handful of extremely energetic neutrinos. One of them, which is called Big Bird, has an energy of about 2 peta-electron volts. To give you an idea of how much energy that is, it is about 1 million times the energy of a dental X-ray. IceCube sees too large a patch of sky to let us determine exactly which blazar Big Bird came from. The enormous increase in gamma ray flux seen by LAT and radio flux by other Toonami telescopes let us finger the exact blazar which is responsible for Big Bird. We have long suspected that blazars are the birthplaces of such neutrinos. What we have been able to establish for the first time is an individual blazar as a potential birthplace of an individual neutrino. This is the first time that we can point and say that blazar is where this neutrino came from. Blazars are the brightest, steadily shining objects in the universe. However, many of the most basic questions about them, such as what is producing this tremendous amount of energy, remain open and unanswered. The same process that produces this neutrino could also produce gamma rays, and that would move us closer to an understanding of emission from near black holes in blazars.